All right. Hello, guys. Welcome to ACM Bootcamp, and this is the third session where we'll be teaching you about gesture controlling and hand tracking using OpenCV and MediaPipe. So, before we jump into the workshop, let's talk a little about who am I. I'm Vinamra Korea. I'm in my second year, in my third year, currently third in VIT Vellore in the computer science branch, and I'm the current research lead at ACM VIT. So yeah, I'm interested in machine learning, deep learning, and also web development. So those are my main interests, and I'll be taking this workshop today. So about the workshop, it will be a code along, and I hope that you have done your environment set up perfectly. The notion which we had sent yesterday in the Discord channel will help you do it. And along with me right now, I hope that you have done environment setup. If you have not, then you can find the Notion in chat, live chat right now, and you can pause the video and make sure that your environment is correctly set up, your Python, pip, and the required packages. So basically, I guess that most of you will have Python installed, and if you don't have pip, then you can find how to set it up here. And the most important thing is that you get all the required packages installed correctly. So for that also we have given a requirements.txt file, and the instructions for that also can be found here. So just give this a read if you have not done it, and if you have done it, which I hope you have, then pretty good. We can start. So let's see what's OpenCV and what's MediaPipe, the technologies that we're going to be dealing with today. So let's talk about computer vision first. What is computer vision? If you guys not familiar with computer vision, it's a part of machine learning where we teach computers how to deal with images and videos, and so that they can understand what's really going on with them. Like, we humans have eyes and we can detect what's around us. Like, I have a laptop in front of me, a phone in my side, and everything, and we've been trained to do that. Like, we've been taking in information, processing that since our childhood, so that's why we are pretty good at it by now. But computers don't have that, so that is where machine learning comes in. We have to train them, and computer vision is that specific part of machine learning where you can teach the computers to develop algorithms, and maybe with the help of neural networks, which is a little complicated. You can teach them how to deal with images and videos and everything. So there is this very popular Python library, OpenCV, where they have provided many tools to deal with images and videos and doing computer vision very easily. You can deal with images, you can alter them, you can apply your models on those images using OpenCV, you can change them. There are many functions, and we'll use it now. So you'll see what OpenCV is really about. And coming to MediaPipe, which is one of the main focus of today's workshop, uh, MediaPipe is a library which has been given by Google. So Google was very nice. What they did, they trained, like, using their own manually created data sets. They created their own data set using a lot of images. And for example, you can see that there are these solutions that they have provided. For example, face detection, face mesh, hands, pose, holistic, hair segmentation, object detection, and etc. The one that we're going to be using today is the hand solution, which MediaPipe has provided. And basically what this means is that we don't have to train any machine learning or deep learning algorithm from the start, because that would require that we know a lot of details of how these algorithms work, how they can be perfected, and how to improve their accuracy and everything. But since Google had so much data and they have such talented engineers, they decided that they'll give this solution, they'll provide it as an open source solution to all of us. So this is where MediaPipe comes in. So yeah, and I already told you about our Notion. So now I hope that your environment set up done correctly. If you have not done it correctly, then I just want you to pause the video and go to the Notion and really quickly just read it and figure out what else you're missing. And if you have done it, let's just start with the code. So yeah. All right, so I've created a new folder named workshop, and in this you can find the requirements.txt. So I'll just start from here. It's completely blank, and this requirements.txt file, as you know, was given in the Discord yesterday. So I'll do everything and along with the environment setup from here. So let's open this with VS Code, which is my favorite editor, And what I'll do now is first I'll set up a virtual environment. So how do I set up this virtual environment? I will do a virtual env. So virtual env is the name of the package which will help me set up the virtual environment, and env is the name of my virtual environment. So when I press enter, you can see that it creates a new virtual env, which I can see here. It's a lib, some scripts, and etc. So now to activate virtual env, that means to get inside this virtual env, what I will do is env scripts activate. And yeah, this is all in the Notion, and you may have already done this, so you don't need to do this again. If you have installed the requirements.txt, you can start just with the code directly. So what I'll do now is I will see what packages I have installed in this virtual environment with pip list. And since it's a freshly created environment, we can see that nothing is there, only pip is there, and some one or two basic libraries are there. So now what I will do is, as said in the Notion, I will do a pip install -r requirements.txt. And what this will do is take all the packages that were mentioned in my requirements.txt, and it will install them for me in this virtual environment. So let's wait for that to happen. And after we're done with this, we'll check again what packages are there in this virtual environment using pip list. So if we go up and we see, initially in pip list there was nothing, only pip and one or two basic libraries. And now that we're in the virtual environment and we have the packages installed, we will do a pip list, and we can see that we have all these packages installed, which came from the requirements.txt. So this is our requirements.txt, and all the packages are hence installed. So finally, let's start with our session with all the coding. And I hope that I go at a pace which is comfortable with you all, and I'll try to be very detailed about what I'm doing. So let's start. I'll create a tester script, tester.py. So let's first import OpenCV. So the first step would of course be importing the necessary libraries, and import media pipe as MP. So you can see that we've imported two libraries here, CV2 and media pipe. CV2 is OpenCV, and media pipe is as MP. We have imported it. So first, let's try to get our media pipe working on static images. So what we can do is let's close this up. Yeah, not media pipe. We need that. And I'll go to Google and I'll search hands. And in images, I'll take any hand. For example, I'll take this image. I'll save the image as in my desktop inside the workshop folder. Okay, sorry. Yeah, inside my workshop folder, I'll save it as maybe hands.jpg. So let's close this up and go back. So now we have a hands.jpg in our project directory. So you can do the same. And now what we'll do, to read a file in OpenCV, what you have to do is cv2.imread, and you have to give in the name of the file. So hands.jpg. So yeah, one second. Yeah, hands.jpg, and this reads our file, and this will return us an image. Now what is this image? Let's put in a variable and see what this is. So I go inside image, and I print what is this image. So you know that images are basically grids of pixels. There are arrays, two-dimensional arrays of pixels. So when we try to print this, I'll run my script using the command python and then the name of my file, and you can see that it comes in the form of an array. This is actually a NumPy array, and if you know NumPy, then you'll recognize what a NumPy array is. But if you don't, there's nothing to worry about. So basically, you can see that there are some values: 253, 253, 241, and basically, an image is consisting of three channels: RGB. But in OpenCV, it is read as BGR, which is blue, green, and red. And there are three values corresponding to every pixel. So every pixel can have these three values of BGR, and each value can range from 0 to 255. So 255 is corresponding to the maximum value of a pixel. For example, if an pixel is 255, 0, 0, that means that the blue value is maximum, which is 255, and the rest of the two values are 0, 0, which means the pixel is blue. And similarly, to get different combinations, we can vary these different pixels and mix them together. So yeah, that was about the image. And now let's see what we can do to display this image. So to display this image using Python, we can do a cv2.imshow, and the first argument here will be the image. For example, let's say the image name is two hands. Like this will be the title of our window, and cv2.imshow. After that, we pass in the image that we want to show. But if I run just this, what will happen is that it will blink and go out for a second because the Python script stops. So as you can see, it just came and it went. So to make it stay, we have to do a cv2.wait key. And when we do this, the image stays here. And you can see that the image that we read as an array, cv2 converts it back into the image format using the three channels, which is the height, the width, the height, and the color channels. I'll come back to that later, and displays it for us. So now this was some of the basics, and let's check out how MediaPipe can help us detect these hands. We displayed the hands, but now we want to detect that there are two hands there and draw some landmarks. So first of all, let's jump back to MediaPipe and go to hands. Okay, so inside hands, we can see that they are doing hand detection, and they have given some overview. You can read this, some pipeline about how you can use the different functions and everything. And basically, in this hands module, there are two models which they have given us pre-trained. So the palm detection model detects your palm, and that is how they recognize that there's a hand in the image, and the hand landmark model, which will give us the landmarks. So basically, they have what they have done is segmented the hand into 21 different landmarks, starting from 0 to 20. So you can see that the tip of the thumb is 4, the tip of the index finger is 8, the tip of the middle finger is 12, similarly 16 and 20, and there are 21 different landmarks. So that will help us identify the different positions and landmarks. And they have given some APIs. So now jumping back to the code, what we'll do is we have imported MediaPipe. Now what we'll do is we will create a variable called mp_hands. This will be mp.solutions. So what is mp.solutions? Mp.solutions consists of all the different solutions that MediaPipe provides. So as you can see, we are in the hands part of it right now, but if we want to use the face tracking part of it, we can use that too. But now we require just the hands part of it. So we will do mp.solutions.hands. This will give us the hands class completely. This mp_hands will contain all of the objects of all of the functions of the hands class in the solution of MediaPipe. Now what we want to do, we want to do hands equals hands dot hands, and this may seem like not hands dot hands, sorry, mp hands dot hands. So what this does basically is, now that we have this hands class, the object of hands class in mp hands, we want to call a specific function. This hands is a specific function of the mp hands class, and we are storing that in hands. Now why did we do that? For example, now if I want to get the results after processing this on the image that I read earlier. Okay, so the image reading should be earlier. I'll just paste this here. We have read the image. Now we want to process this image. So what I will do is hands.process, and I'll pass in the image. Okay, so what is happening here is we have read the image, which comes as a numpy array, and in hands, which is this object where we have taken this function hands, there's another method called process, which will process this image, and it will give us the results in this results. But the thing is that MediaPipe only works with RGB images. It doesn't work with BGR images, and BGR is the format that OpenCV is reading this into. So what we need to do is we need to convert our image into RGB format. So what we'll do is image RGB equals cv2 dot convert color, and we need to pass in our image, and we need to pass in what color do we want to change it into. So it becomes cv2 dot color. It becomes BGR to RGB. So what's happening here is we pass in this image, and we say that we want to convert it from BGR format to RGB format, and this is our image RGB. So now to process this, we will give in the image RGB, and after we give this, let's print what the results. So as you can see, the hand is still displayed because of cv2.imshow, and there is a result printed, which is a class, but there's not much that we can derive from this class. So there's an attribute inside this results, which is multi-hand landmarks. And let me just show what will happen if we try to print that. Multi-hand landmarks. And all of this you can find in the MediaPipe solution API as well. For example, you can see that they have also done the similar thing, mp.solutions.hands, and then they have done mp_hands.hands, the similar way we have done. So Now when we try to print this, one second, I'll just close this up, python tester.py. Now when we try to print it, you can see that, let me just expand this. You can see that a lot of coordinates were printed in X, Y, and Z. And what this is basically, let's go at the start. It is an array. As you can see from the square bracket, it's an array and it closes here. And basically, what is happening here is there are 21 landmarks in each hand, as I told you. So there are 21 landmarks, and since we have two hands in this image, so there should be a total of 42 landmarks. So let's see where the comma is. Where, yeah, so here we can see a comma is there, which means that all of these landmarks before this comma are the first element of the list, and all of these landmarks after the comma are the second element of the list. So basically we have got all these x, y, and z coordinates, which is between -1 to 1. So now we have printed. Now let's try to draw it. So what we will do is, for hand LMS in results dot multi hand landmarks, my bad. So what is happening is, what is this hand elements? Like I told you, this is a list containing two elements if there are two hands, and one element if there is only one hand. And that one element itself is a complete collection of dictionaries. Like if there is only one hand, the one element will be 21 landmarks. And if there are two hands, there will be two elements. So this hand elements will iterate over this list, and it will be each of these two hands. So what will happen now is, what we'll try to do, first we need a drawing tool. So MediaPipe already provides us with a drawing tool, and we'll just import it. Draw tools equals mp dot solutions dot drawing utils. So now we have the draw tools imported, and now what we'll do is, we'll just do draw tools dot draw landmarks. Draw tools dot draw landmarks. We'll pass in the image on which we want to draw the landmarks, and after that we will pass in our mp hands dot hands connection. Just one second, let me refer the API once more. Let's see what they have given here in the drawing portion. So yeah, they have given the image, the hand landmarks, and the hand connections. So we need the hand landmarks, and the hand landmarks, as we have written here, it is hand LMS. So image comma hand LMS comma mp hands dot hand connections. And now what will happen when I try to uh, run the script again? So one second, python tester.py, and as you can see, these two hands were detected successfully, and the landmarks were drawn on them. So there are 21 landmarks on the left hand, and there are 21 landmarks on the right hand. So that was detected successfully. And what we can also do is, they have given us the ability to detect a maximum of one hands also, two hands also, and whatever number of hands you want. So we can change that by using this variable max num hands, which we pass as an argument in this hands function. So we can do max num hands equals 1. And now what will happen when we run the script again? Only one hand was detected. So this hand was detected and this was not. So let's close this. And this was a little boring since it's a static image, but now we'll start with the fun part, where you can try it with your own webcam. Your own hand will be detected. So let's remove this thing real quick. And yeah, I'll remove this part. I'll comment out this part because we'll need it. I'll results also we need it. I'll remove the print part. And yeah, so how do we turn our webcam on with the computer with OpenCV? So for that, what we need to do is capture equals cv2 dot video capture, and inside video capture, you may either put 0 or 1. It will vary from person to person depending on what webcam they're using. For example, if I was using an external webcam for my laptop, it would have worked with 1. But since I'm using the integrated webcam in my laptop, this will be 0. So if it doesn't work with 0 for you, then try using 1. So this capture will basically open our camera, and it will start recording these frames. So now we need an infinite loop, which is while true, and we want to read these frames. So we'll take two variables, success comma image is equals to capture dot read. So now what's happening is, these frames that we're getting from video capture inside capture, we are reading them, and it basically, this read functions returns two things. It returns a boolean value whether we were successfully able to read the frames or not, and the second is the image. So this image is the numpy array as we had read earlier in the static image. So now this will be just in the case of our webcam. So let's also comment out this portion. And now what we'll do is, we had commented out this portion where we're converting the image we got to a RGB image. So let's take that and let's convert our image into an RGB image. Now the same thing is happening, and let's process the results. So I'll uncomment this, and as you can see, we're taking the image from our video, our webcam. I'll just run the script in a moment and show you it's working, and then we're converting it into an RGB image, and then these are the results. But before drawing, just let me show you whether my webcam is working or not. So one thing that we need to do is we need to show it inside this infinite loop. So let's put this inside the infinite loop, and always keep the indentation in mind, because in Python, if you don't indent correctly, then it won't work. So yeah, now I'll change the name to video feed, the title of our window, where we'll see our webcam, video feed. This will be image, and what we can do is key is equals to cv2.wait key. So what this wait key does basically is, whenever you press a key, for example, and inside videos this needs to be 1, is just something that we require to do. So whenever, for example, if I want to exit my infinite loop using my escape key, so what I can do is I can take this wait key. Whenever escape is being pressed, it will come to this key, and now I can check if key is equals 27. And 27, why 27? Because 27 is the key corresponding to escape, the escape top left key on your keyboard. What we can do here, if key equals 27, we can break. So after breaking, it will come up of the infinite loop, and then we can do capture dot release, and we can do cv2 dot destroy all windows. So now let's see what will happen if I run this. My camera will open up. As you can see my face, no hand is my hand is being detected right now, but you can't tell because I have not shown on my hand what is really happening. So let's do that right now, and I will just turn this off by pressing my escape key. So I press my escape and it stopped. So now after we have the results, what we can do is, if we have results dot multi hand landmarks. Why we have written this if statement? Because, for example, when when the camera is only seeing my face, there are no results. Because MediaPipe is not detecting any hands, and I've used the hands thing only. So we need to check if we are getting any hands in our detection. What we need to do, the same thing that we had done earlier for hand LMS in results dot multi hand landmark, and now we want to draw. So draw tools dot draw landmarks, and first we need to pass in the image, then we need to pass in hand LMS, and then we need to pass in MP hands dot hand connections. So yeah, let me explain this again. What we were doing here was, this was an array consisting of two hands if like two hands are detected, and one hand if one hand is detected. So this hand LMS will be the collection of all the landmarks, and now we want to draw it. So now when I open my webcam, let's see what happens. Result is not defined. Okay, result is not defined because I had used results. So just put an S there, and let's try to run it again. Now my camera opens up again, and as you can see, when I put my hand up, you can see that my hands, all the landmarks get detected. And since my max num hands is still 2, both of my hands get detected. So I hope that this is working for you as well right now. And let's try to play with this a little bit. Like I had shown you that if you put max num hands equals 1 here, let's see what happens then. So now when I put both of my hands, you can see that only one of them gets detected, the one which I put up first. So this is my right hand and this is my left hand. So if I put my right hand up first and then my left hand, then you can see that the left one doesn't get detected. But if I put my left hand first and then the right one, obviously that one gets detected. So that is how you can, determine how many hands do you want. So now pressing the escape key, we escape. So let's take a breather, and I hope that you guys have caught up till now, and I'll wait for 1 minute for you guys to process this. Okay, so I hope that all of you are up to whatever we have done till now. And now what we want to do, let's with the interesting stuff. If you've seen what we are building in the Instagram reel that we put out, you saw that there was a scroll functionality. So let's first try to implement the scroll functionality. That is, what we want basically is that when we close our fist, we want the screen to go down, and when we open our fist, when all of our fingers are visible, we want the screen to go up. So what we want to do is first we want to create a new okay, let's create a new hand tracking module which will be clearly visible right now. Hand tracking module.py. So what is the purpose of this? We want to create a class. We want to create a class with the necessary functions that we can use again and again instead of writing code randomly here in the tester.py file. So we can define the methods here and then we can use them again and again. So what we'll do here is first we'll import cv2, then we will import media pipe as MP, and let's just copy the these things after removing the maximum hands because we don't really need that, and we put that here, and basically we're good to go. Now we want to start with our class, so let's name the class as hand detector, and inside this let's make a function called landmark list. So this will be our first major function, landmark list. What this will give us is basically, let's try something. We printed the result of multi-hand landmarks, so what we'll do right now is, yeah, so in any function in Python, what you need to pass it first is self. What self means is that the function is taking an object of the object that called itself. For example, like if there's an object named obj1 which calls this lm list, then this self is that object itself, and this is something that we need to do in every Python function. So don't worry about that, just type in self, and after that we need to get the image. After this, what we want to do is we want to get this image RGB and the results. Let's copy that and we'll paste it here. So image RGB will be the image we have taken, and we'll convert it to image RGB, and the results will be the results. Now what we want to do is, if results dot multi hand landmarks, just like we had done earlier, then we want to iterate over the two hands in the list, and lms in results dot multi hand landmarks. And for this, what we want to do is, let's see again when we printed the multi-hand landmarks, what it was exactly. So let's print the results dot multi-hand landmarks. Let's see what the tester.py gives us. Keeping the video feed aside, okay, result, my bad, it will be results again. And basically, let's ignore this one. When I'm putting my hand up, there are some landmarks coming in. So I'll just press escape and see what's happening. So as you can see, these landmarks are dictionaries consisting of X, Y, and Z coordinates. And for our purposes today, we want these X and Y coordinates, and we want to basically detect which landmark in our hand is at which coordinate so that we can track them in real time. So this X and Y are what we need. And I also want to see what is the shape of the image that we are getting from our video feed. So let's try to print image.shape. And I'll comment out imshow because I don't need the video feed right now. Let's see. As you can see, 480 times 640 times 3. So what this 480 is, the 480 is the height of our image. Let's stop this. 1 second. Yeah. So 480 is the height of our image. 640 is the width of our image. And what is this 3? This 3 is the color channels that I told you about earlier. BGR, blue, green, and red. So this is the shape of our image that we're getting in, and the coordinates that we were getting in, those were in fractions. For example, 0.28, 0.56. So what we want to do is we want to multiply this 0.28, which is our, for example, say the landmark of our, the position of our index finger, the tip of our index finger, and we want to multiply that. X will be multiplied by 640. So that will give us um, a value which is the coordinate of that tip of the index finger in the image. So what we want to do in the hand want to enumerate the hand LMS dot landmark. What enumerate does, if you don't know, one second. If you don't know what enumerate does, it takes every element in an iterable and it turns it into a tuple. It turns it into many tuples. For example, if there is I love ACM, then enumerate will do it. It will convert it into 1 comma I, 2 comma love, and 3 comma ACM. So it will give them IDs from 1 and from 0 actually, and it will like keep on giving them IDs for every separate element. So now what we will do is for ID comma landmark in enumerate. So what will happen here is basically, let's check out this again. Every landmark dictionary here, this will be considered as the value. For example, if I scroll to the top here, for example, see here a new array starts. So this will be 0 comma this complete landmark. This will be 1 comma this complete landmark. This will be 2 comma this complete landmark. So we are iterating over that. Now what we want to do is height comma width comma channels equals our image dot shape, and as we had already printed, we know that height will be 480, width will be 640, and c will be 3. We don't need the c, but since we have got to take it, we took it in the c variable. So now our coordinate of x and our coordinate of y, this will become equals to our landmark dot x times our width. And we want to maintain it as an integer, since it will be a lot easier to work with integers rather than floats. We will do integer cy will become landmark dot y times h. So to explain again what's going on, landmark dot x is this value for every and w width, which is 640. So we are getting our c coordinates in our landmarks. And now what we want to do is we want to create a list, landmark list, which is an empty list at the beginning. And we want to put lm list dot append. We will put first the id, which was the first thing that we got here, 0 1 2 3, like that. And we want to put the x coordinate and we want to put the y coordinate. And if you're still confused about what's going on here, let's just return this lm list for once and see what's happening. So inside my tester.py, I'll remove all of this code because now we don't need it. We just need our capture read. What we'll do is lm list. First, we need to import our hand tracking module. So this is the name of the file, hand tracking module. So what we want to do now is from hand tracking module import, we want to import the class that we created. This is the hand detector class. So we will import the hand detector, and now we will take a variable called detector, which will be an object of this hand detector class. So from the hand tracking module, we have imported this class hand detector, and we have stored it in an object called detector. So we want to show the image again, and what we want now is to call detector dot lm list. What is this dot lm list? This is the function that we created just now, and what it takes is an image. Don't worry about the self, just the image. So we'll pass in an image here, and we'll get the output, which will be the lm list equals in this. Now let's print this and see what's really going on. And let's start my video feed. Yeah, see, at the beginning, when only my face is visible, there is nothing but empty lists, and this random lists are coming because there are some faulty uh, hand detections. But when I put my hand up here, you can see that the empty list goes away, that these numbers are there. So let's just stop my video feed for a second and see what's really going on here. If you can see, there's 20, 98, 198, and if you trace it back, it goes back to 0 here, the beginning of this 2D list. So 0 comma 2 coordinates, 1 comma 2 coordinates, and for the hand that I put up, it is detecting these landmarks, these 21 landmarks from 0 to 21, and we have got all of their coordinates. So our job will be a lot easier now. And since we want to track our hands here, what we'll do is we want to draw the connections. So we will put a draw equals true here, and equals true means that this will be default true. That means even if we don't put it as true or false, it will be as true. Default. If you want to change it, we'll have to give it as false. So now what we'll do is if draw, then this will be inside hand LMS, of course. So if draw, that means if draw is equals true, what we want to do is draw tools dot draw landmarks and we'll put in image here. We will put in hand LMS here, and we have done this already, so you guys know what's going on. And we will put in hand connections here. MP hands.hand connections. Yeah. So and now that we have drawn on the image, we need to return the image also. So we'll return the image as img, and let's save it. And when we go back here with the lm list, we want to take the image img. So now what will happen is, now, as you can see that even though I have not written any detection code inside my tester.py, but I have written it inside my the hand tracking module lmlist function, it is drawing my connections, and you can see that even those are being printed. And now, if I put it down, you can see that there's a faulty detection behind me. But if I bring my face here, you can see that it goes empty. So there are some faulty detections because the color of my background is kind of similar to the skin color. But as you can see, when I put my hand here, it's completely being detected. So don't mind my background, sorry for that. And yeah, this was the first and most important function of our hand detector class. Now what we want to do is, let's do something interesting. What we want to do is, if I put up one finger, then I want to show it on the screen that it's one finger, and I want to count the number of fingers which are up. So how can we do that? So first I want to explain something to you using a whiteboard. And yeah. So basically how OpenCV coordinates work is, for example, if this is your screen, then the 0,0 coordinates are at the top left part of your screen. So this is the 0,0 coordinate. And as you go towards the right, the x coordinate increases. And as you go down, the y coordinate increases. So for example, if you're here, then it will be 0,10. And if you're further down, it will be 0,100. This is contrary to the old maths that we have seen coordinate geometry in our schools, that y increases upwards from 0,0 here. But here the 0,0 is this. So you can think of it as like this region. The whole camera is this region inside the OpenCV. So yeah. So now coming back to this, when we want to count the number of fingers, what happens is, let me just turn on my camera once again, and I'll show you what I'm talking about. So basically, when I put my hands up and it is open, you can see that the y coordinates of the tip is less than the y coordinates of the landmark 2 below it. For example, if I go back to media pipe, you can see that 8 is the tip of the index finger and 6 is the two landmarks below this tip of the index finger. So when my hands are open, the 8 is above the 6, but as I showed you here, the y coordinate of 8 is actually less than 6. So when it is open, we know that 8 will be less than 6, the y coordinate. But in the case of the thumb, let me bring this back. In the case of the thumb, what happens is, my thumb, when it closes, thumb closes like this, the y coordinate doesn't go down below the 2 below this. So what we can do is, the x coordinate of the thumb is what we need. The x coordinate of the tip of the thumb, it actually goes below the 3. For example, this 4, the x coordinate of this 4 goes below this 3, and let's just code it and you'll see what I'm talking about. So let's stop this, and let's create a new class. For example, let's name the new class as fingers up. Fingers up, and what this will take first is the self itself. Then we will give in the image, and then we will give in the lm list. I don't think we need the image here, so let's remove that. Yeah. So first we'll create an empty array, which is fingers. And then what we'll do is, we'll check for the thumb at first. So if lm list consists of all the coordinates of our landmarks, as you've seen already. So if lm list of 4, what is lm list of 4? The tip of the thumb. And of 1, so if the x coordinate of the tip of the thumb is actually less than lm list of 3 of 1. So I have compared the x coordinates of 4 and 3. That means, one second, fingers dot append 1. And if it is not the case, then fingers dot append 0. So what will happen is, if the finger is okay, I think I've put it as opposite. If the x coordinate is less, then it will be 0, and if it is greater, it will be 1. And for the rest of the fingers, what we can do is, the rest of the fingers require that we have an array called tip IDs. And tip IDs can be taken as, let's see what are the tip IDs of the rest of the four fingers: 8, 12, 16, and 20. So we have 8, 12, 16, 20. And let's iterate over this. So for ID in tip IDs, if LM list of ID of, now we need the Y coordinate. So the Y coordinate of this ID will be 2. And if it is less than the LM list of ID of 2, ID minus 2, my bad. So what we're doing basically, ID minus 2. So what we're doing basically is we're comparing the Y coordinate of 8 with the Y coordinate of 6, the Y coordinate of 12 with the Y coordinate of 10, and the Y coordinate of 16 with 14, 20 with 18. So if Y coordinate of 8 is less than 6, which means that it is above, as I showed you, Y increases down. So if it is less than 6, which means it is up, then we will do fingers dot append 1. Fingers dot append 1, else fingers dot append 0. And now finally our function is complete. We will return the fingers. Let's test out if it works correctly. So we'll, in the tester class, okay, let's create a new scroll feature class. We'll call this new scroll feature script. So scroll feature dot py, since that is what we're trying to accomplish. We'll copy the code from the tester class and we'll change some things. For example, we remove this unnecessary comments, we'll remove this printing of LMList, and this is all needed here. We don't need this empty hands in this thing because we're already doing that in the hand tracking module. And we're capturing the video and detector is working fine. Okay, so now what we will do is, if LM list, that means if we get in list, that means a hand is being detected, then what we will do is fingers equals detector dot fingers up, and what we needed to pass was the LM list. So we'll pass in the LM list and then we'll print it. Not test of the py, it's my bad. We created a new class, so let's just clear this out and create a new one. So now we want to run our scroll feature. So scroll feature.py, let's see what happens. My camera will open up. Tip IDs is not defined. Okay, 1 second, let's see what went wrong there. For tip IDs equals this, tip IDs, oh okay, this is tips IDs. So let's just keep it as tip IDs. Now let's see if it works. So when I put all of my fingers up, you can see that all of the variables, all of the elements in the list are 1, 1, 1, 1, 1. Now, if I put only one up, then you can see that it is 0, 1, 0, 0, 0. And if I close all of them, it becomes 0, 0, 0, 0, 0. So we can correctly count the number of fingers which are up using this. For example, if I put only 2 up, then you can see that only 2 of this go up. But this is not very convenient to look at this in the form of an array. So what we'll do is, let's just close this by clicking the escape thing. And just give me a minute. Yeah, so what we want to do now is we want to create a count variable. So let this count be equal to 0, and every time we detect the finger, we will do count plus equals 1. So below the fingers dot append 1, we will do count plus equals 1. And what we want to do is, let's put a draw equals true here also. So we'll put a draw equals true, and if we want to draw, then what we will do is we will put some text. Now, how do we put text in OpenCV? Let's look that up. cv2 dot put text. Yep. So it takes basically some parameters, cv2 dot put text. So let's see what is the first parameter after I write cv2 dot put text. The first one that we take is the image itself. So let's give in the image. The second one that we take is a text. So the text will be the count. But since it's an integer, we want to convert it to a string. So we'll put in count here. And then what we want to do is the origin, which is the coordinates of the lower bottom left corner of the text string. So for example, if this is our image, then the bottom left corner, this corner of uska coordinates. So let's give it as, for example, let's say 50, 50. And 50 comma 50 means that since this is 0 comma 0, if this is our screen, if this is 0 comma 0, then 50 here and 50 here, so somewhere here. Now what else do we need? Let's see. We want to give the font. So font, anything you can choose. CV2 dot font. I'll select the Hershey Simplex one. Then we want to give the font scale. The font scale is the thing. For example, if I give it as 3, then it will multiply the default font by 3 times the size. And then we want to give the thickness. The last two are optional, so we don't need to give them. But let's give the thickness. The thickness, let it be 3 pixels only. So I guess it's correct. Image, the text, the origin, the font scale, and acha, I missed the color, my bad. So after the font scale, we need to give the image. Okay, so this is important. Like I said, the images in OpenCV consist of 3 channels, B, G, R. So if I put it as 255, 0, 255, this will be blue plus 0 of green, that means no green, blue plus red. So blue plus red gives us purple in OpenCV. So we'll see that. And now that we have drawn on our image, we want to return the image. So now let's go back to our scroll feature.py. We'll get fingers, comma image. And now let's comment out the printing of fingers. And now you'll see something crazy. Let's see. Okay, image is not defined here. Let's see. We didn't pass the image in the hand tracking module. My bad. So let's put the image in the hand tracking module in the fingers up function. And inside the fingers up, let's first give the image and then this. Now let's try. Okay, so now what is happening is, okay, you can see that there's a 5, but it's actually to the like um, top left, I see, yeah, and it's not clearly visible. So I just changed the coordinates so that we can see it more easily. But yeah, what we'll do is instead of 50 comma 50, we'll increase the y coordinate because the x seems to be fine. We'll make this 100, for example. So now let's try to run this. As you can see, now it is clearly visible. If I hold up one finger, it shows 1, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. And it's very fast, as you can see. So that is the power of OpenCV and Media 5. 3, 4, 5. And we can correctly count how many fingers we have now. 2, 3, 4, 5. Okay, so enough playing around with this. Our fingers up module is complete. And now our scroll feature, now we can scroll very easily using our fist closed and our fist open. And I'll show you how. So for that, we'll need Pi Auto GUI. And I'll tell you what it is. Pi Auto GUI as Pi. So we have imported a module named Pi Auto GUI as Pi. What is Pi Auto GUI? Let's Google it. Pi Auto GUI. So PyAutoGui lets you control, lets your Python script control the mouse and keyboard. So this is PyAutoGui. What is happening is basically, if you want your Python script to be able to control your mouse, then you need PyAutoGui. So there are many methods here. For example, click. For example, if you do PyAutoGui.click, it will click. If you do move, then it will move the mouse cursor. If you move to, then you can give in the coordinates where you want to move to, and this will be important later on. And that's about it about PyAutoGui. And let's see now what we want to do. If all of our fingers are closed, that means the fingers array will be 0 comma 0 comma 0 comma 0 comma 0. Then we want to do pi dot scroll, and we want to give the number of clicks. So if I give minus 50, that means that it will go downwards. Minus 50 means downwards, plus 50 means upwards. So let's give an else if condition, and if fingers equals, acha, there will be an equals above also, my bad. If fingers equals, let's say all of our fingers are open. I gave 1 comma 1 comma 1 comma 1 comma 1, and I want to scroll up on this. So 50 clicks upwards. Now here we'll see the magic. Let's open this up. I'll run the script and I'll show you how the scroll is working. So now my camera is on and it's detecting weird weird hand behind me. Let's just pin my camera on here. I'll pin my camera so that you can see. Now let's see. When I close my fist, you can see that it's scrolling down, and when I open my fist, you can see that it's scrolling up. And since we are already drawing the 0 and the 5, you can see that it is also being shown. We don't need that, but as you can see, when I open my fist, it scrolls up, and when I close my fist, it scrolls down. So now you can feel like Iron Man with this scroll feature. And you can map any number of fingers you want to this. Since I have mapped the close in OpenFist, it works like that. So yeah, that was for our scroll feature. So I hope that most of you have gotten to the scroll feature by now. And yeah. So for the next part, now what you want to do is let's jump into the the volume control thing. So now what we want to do is, with the help of our index and thumb, we want to control the volume of our system. So how can we do that? Let's see. First, we need to find the distance between our these two things. Let me show you. We want to control our volume using the distance between the tip of the index finger and the tip of the thumb. So let me just open my camera and show you what I mean once again. So what we want to do is, when I decrease the distance between my index and my thumb, I want to decrease the volume. And when I increase the distance between my thumb and index, I want to increase the volume. That is how I want it to work. So to make that work, let's see what we should do. Let's create a new volume control .py. And for this, first, let's copy the tester.py code. And let's remove some unwanted things. For example, we don't want to print the LM list yet again. Let's remove this altogether. So basically nothing is happening here, which is important. We're importing CV2, media pipe, hand tracking module, making an object of the hand detector. Then we're doing the capture, we're getting the frames, we're getting the LM list. We're showing the webcam feed. And now what we want to do is, we want to make a find distance function that will find the distance between any two landmarks. So what to do now is find distance. And what this will take at first is self, as with every function. First point, the second point, the image, and the LM list. And we'll do a draw equals false. And I'll show you why we did that. So first we want to get the x and y coordinates of the 2 points that we want. So x1 comma y1 equals lm list of p1 of from 1. So what is happening here is, lm list of p1, for example, if p1 is 4, then 4 is our tip of the thumb. So we will get the 3 values corresponding to the tip of the thumb, which is, the first one will be the id, the second one will be the x coordinate, and the third one will be the y coordinate. So we want the second and third values, which is the x and the y coordinate. So 1 is the index corresponding to the second element in all programming languages, and from 1 to 2 we'll get the x and y coordinates. Similarly, we copy and paste this and we name it as x2 comma y2 equals lm list of p2. And now let me ask you guys something. We have all done basic coordinate geometry. So for example, if I have this x-axis and y-axis and I have 2 points, so this has an x1 and a y1, and this has an x2 and a y2. What is the distance between these 2 points? We have done basic Euclidean coordinate geometry, and we know the formula for Euclidean distance. If this is the difference in their heights, which is y2 minus y1, and if this is the distance between their x coordinates, which is x2 minus x1, then we all know that this is a right angle triangle, and the distance formula here is under root of x2 minus x1 square plus y2 minus y1 square, which we also known as the hypergeneous function. So what we want to do is, Python gives us a very easy way to do this. We will import the math library in the hand tracking module, which is in Python itself. And then what we will do is math.hypot x2 minus x1 comma y2 minus y1. So what this will do is, this will take the difference of x2 and x1 and the difference of y2 and y1, and it will calculate the hypergeneous, which is the distance between these 2 points, and this we will store in a variable called length, and we'll return this length. Simple as that. So now what I want to do inside the volume control thing, if we have an lm list, because as I said earlier, this if is necessary because if only our face is there, then there will be no lm list, it will be empty. So if we have an lm list, then we want to call the detector dot find distance and we want to give the 2 points. What are the 2 points that we want? As I said, for the volume control part, we want 8 and we want 4. So we will put in 4, comma 8, comma the image and the LM list. And let's see what the draw was. The draw was false by default, so that's okay. We have not implemented the draw yet, but let's see what we get here. So let's take this inside an length variable and we'll print this length. Let's see. Let's freshen up the terminal. Python volume control.py. Now my camera will open up again, and as you can see, when I bring my finger up, as I close the distance between my thumb and my index finger, the tip of them, you can see that it goes down to as much as 20s and the 10s. But when I start to increase them, as you can see, I'm increasing them, it's increasing. It goes to 60, it goes to 80, 100. As you can see, it's in the hundreds now. And as I increase it to the maximum, you can see that it goes to like 200 above. So as you can see, the distance function is working, but the terminal is still not appealing. So to see, let's make it more visually appealing with the draw function. And don't worry, this is the final function in our hand tracking module. With these three functions, we can rock the world. We can do anything. All of the rest of the things that we'll be learning in the workshop will be done using this three only. So let's complete this one. Yeah. What we want to do is if draw, we want to put a line between these 2 points. What are the 2 points I'm talking about? This and this. We want to put a line between that. So cv2.line. We want to give in at first the image that we want to draw this line in on. Then we want to give in the two coordinates, which is x1 comma y1, then x2 comma y2, because we know that to make a line we need 2 points. So x1 comma y1, x2 comma y2. Now what we want to give is, let's just look up the cv2.line API once, and let's open this link by Geeks for Geeks. And as I have said, the image we have passed in, the start point we have passed in, the end point we have passed in. We just need the color and the thickness. So for the color, as I said, let's make it purple in color by 255, 0, 255, which is blue plus red in the BGR format. And for the thickness in pixels, let's take it as 3 pixels. So we'll say this and we'll return the image. And now inside the volume control, we will take in the length comma the image, and let's see what happens now. So my camera turns on and no line is being drawn. Acha, that is because we didn't pass the draw in as true. So as you can see, the draw was default as false here. So we need to make it true here explicitly. So after the LM list, we will pass in true. And now let's try to run it again. And now you can see that there's a line between the tip of my thumb and the tip of my index finger. I'm sorry about the weird hand being detected behind me. Let me just change my position, and as you can see, when I change the distance between my tip of the thumb and the tip of the index finger, the distance, the line also changes. But this is still not very visually appealing, so we'll improve upon this. Okay, so we've been learning a lot since the start of this session, and let's take a 5-minute break. In this break, we'll also be giving the DSW attendance form, and we require that all of you fill it. So if you have any doubts, then you can ask them in the Discord or the YouTube live chat, and please make sure that you fill the attendance form, and let's take a break for 5 minutes. Okay, guys, so we're back. I hope that you had time to get some fresh air in the break, and let's complete our volume control part. But before that, I want to show you a GitHub repository that we'll be using the code from, and the link will be going in the YouTube live chat as well right now. The name of it is PyCo, and this link will be going in the chat right now. You guys can also see it. So, yeah. This PyCom module has been developed by Andromedas, and he has done great work. So what we need this for is basically this helps us control our Python. This helps us control our volume in the system of our system using Python scripts using this library. So even to not go to the trouble of reading all of his code, he has given us a simple usage code which we can copy and paste in our volume control module. So I just copy this. You can also copy this from the link that was in the live chat. And let's come to the volume control part. And after coming to the volume control part, after the imports are done, we will paste the code that we copied from the GitHub repository. And first of all, there are a few imports which we require, and this object initializations and some parameters being passed. These four are the basic functions that we will require. And the first one is a volume.getMute, which tells us if our system is mute. So we don't need this right now. We'll just comment this out. We have volume.getMaster volume level, which gives us the master volume level of our computers. So we'll comment this also. Now these two are the important ones that we require as of now. Volume.getVolumeRange and volume.setMaster volume level. What this will do, let's try to print this. Okay, let's just comment all of this out. Okay, let's remove this. I'll comment the part till here. I'll comment the last line also, and I'll print this. Let's see what it gives. So as you can see, what was given was minus 30, 0, 2. What is this minus 30? This minus 30 is the lower range of the volume that PyCo detects. So it's not 0 to 100 as you can see, and we'll need to change that later on, but it will be different for you. Since I'm wearing earphones, my earphones have a maximum volume of 100 only, but the range is different. So it's showing as minus 30, but if you're on your laptop speakers, then you will, if you're not wearing any earphones, it will be minus 65, and this will be 0 only, and this will be 0.03 something. So minus 30 to 0, and 2 is the range in which this is varies. For example, minus 30 to 28, then 26, like that it varies. So we require the minimum volume and the maximum volume. For example, minus 30 corresponds to 0 in our system, and 0 corresponds to 100 in our system. So I'll explain this again, don't worry. Let's just uncomment all of this. And what we'll do is let's comment the set master volume level. What the set master volume level is about is the set master volume level will allow us to set our master volume to the value which is given here. So this value is minus 20 as of now, but we need to change it according to the length, the distance between our tip of the index finger and the tip of the thumb. So what we want to do here is we want to take a variable volume range equals volume.getVolumeRange. So what will happen here is this three variable tuple minus 30, 0, 2 will be in this volume range, and now the minimum volume can be taken as volume range of 0. The maximum volume can be taken as the volume range of 1. So now we have the minimum volume, now we have the maximum volume. This will be minus 30 for me, minus 65 for you if you're not wearing earphones, and this will be 0 for the both of us. Now let's comment out this one since we don't need this right now. So let me tell you something. We have this confusing range of minus 30 as the lowest volume possible and this 0 as the maximum possible. But our one second, I'll just clear this out again. Let's see what was the length. The length that we were printing earlier, the distance between the tip of the index finger and the tip of the thumb. So we saw that it went to a maximum of 200. I went. Let's try it again. Okay. Let's not haggle over the past, and we'll print this length. My webcam should open up right now, and as you can see, if I close my fingers, the minimum volume is around 20. So 20 is a good thing, and okay, it goes to 10, but 20 is a good range for the minimum volume. And when I increase the distance between my these two fingers, this goes to around 200. So 200 is a good range. So what we will do now is pressing escape and exiting the infinite loop. what we will do now is we want to convert these 20 to 200, this range to 20 should map to the minimum volume, which is -30, and this 200 distance should map to the 0. 0 is the maximum volume. If you catch my drift, this -30 corresponds to the 0 volume. This is the volume. This is the volume according to PICO, and this is the distance between our fingers. Yep. So we want to convert this 20 to 200 into -30 to 0. And luckily, NumPy has a very useful function for this. So we'll just import NumPy as NP. And now what we'll do is we won't print the length, but we will do np.interp. So what this interp does is it will take the length, and then we want to give the range in which this length is supposed to be. So the length we know is supposed to be between 20 to 200. So I'll give in 20 to 200, and then we want to give the range to which we want to convert this. So we want to convert this to from the minimum volume to the maximum volume. So what will happen here is it will take the length first, it will find where it is between this interval, and it will map this range into this range, so that now we will get our volume in the form of the PICO volume. So now what we can do is, now the line that we commented earlier, volume.set master volume level, we'll just take this out. We'll put it here, proper indentation. So volume.set master volume level, and instead of -20, we'll put in the volume that we just calculated. So now our volume control should work perfectly, even though it will not be very visual. I'll just open up my volume bar and let the camera open up. So as you can see, if I close the distance between my fingers, it goes to 0. If I slowly start increasing it, then you can see it goes to 100. And if I want it to be 50, then I can put it here. If I want it to be 0, I can again shrink it. If I want it to be 100, I can again increase it. So the volume control works perfectly with the distance between my fingers. But it's still not very visually appealing because I have to open up my volume bar again and again to see what's really going on. So to tackle that, what we can do is we can set up some volume bar adjacent to my face in the camera itself. So what we will do is cv2.rectangle. We'll put up a rectangle. Acha, first of all, we don't need to put the rectangle at first. Let's see if we can do with a volume percentage, for example. So like I said, we have this volume range. Now we have the volume range proportional to the length. So the length is from 20 to 200. And we want to convert this into a percentage of 0 to 100, the volume percentage. So we'll use the same function, np.interp. And what we will do is the volume percentage will become the length translated from 20 to 200 to 0 to 100. So now we will get the volume percentage, and now we want to use the cv2.putText, which we had used in the fingers up function. So we'll just copy this put text and we'll paste it here. And now we need to change this. So volume percentage will be a float actually. So first we need to convert it into an int, volume percentage. And since now we have a string, after converting into an int and making it a string, we can also add a percentage symbol so that it will look nice. And now what will happen is at 50, 100, there will be a volume percentage which is calculated using this interp function with this font scale with the purple color. Let's make it as blue color, BGR. So B is 255, G is 0, and R is 0, and 3 is the thickness. So now let's see what's happening. My camera opens up again. And as you can see, I have a volume percentage which is very clear on the top left part of the screen. As I start decreasing it, the volume decreases. It goes down to 0. As I increase it, it's a little big, so we can decrease the size. We'll decrease that, no problem. But it varies according to my distance between my fingers. So let's close this up. And we'll decrease the font scale to maybe 1 itself, and that's it. But now we also want to put a volume bar below this percentage so that it's more visually appealing. So what we'll do is we'll put a rectangle. Now let's look up the rectangle API, cv2.rectangle. What do we need in the rectangle? We need first of all the image that we're passing in. So the image, comma. Then we need the start point. The start point is the starting coordinate of the rectangle, which is the top left coordinate, this coordinate. So this will put as, okay, the percentage we're putting at 50, 100. So why not just put it at, why not put the volume bar just below this percentage? So to put it below this percentage, we need the x coordinate as 50 only. and the y coordinate, let it be a little below 100, so let it be 120. Okay, and now we need the bottom right. We need the endpoint. Endpoint is the ending coordinates of the rectangle, which is this coordinate, the bottom right. Start point was this, endpoint is this. So the endpoint will be, let's say, if we have the start point as 50, let the thickness be 30. So 50 plus 30 becomes 80. So the x deviation is 30, which means the thickness of our volume bar will be 30 pixels. And let the height of it, the height is the major thing, we want it to be very big. So from 120, let's add 150, so that will become approximately 270. So we have these two things now. And now what we want is, we want a color and a thickness. Okay, so for color, let's put blue only, since our volume percentage is also blue. So 255 comma 0 comma 0, and let the thickness be 3 pixels. Now let's see what's happening. As you can see, there's a volume bar, but it's an empty volume bar. It doesn't move. It's just staying there. The volume percentage is the only thing moving now. But we have successfully put a volume bar. So let's see how we can get the volume bar to move. So what we need now is, let me get back to the video this out. So again, coming back to the range, our length the length between our fingers varies between 20 to 200, and we have this volume bar. Let's see what is the starting coordinates. The starting coordinates of this rectangle is 50 comma 120, and the ending coordinates here is 80 comma 270. So the length of this is 150, and it varies from 270 to 120. Now here's the confusing part. See, 270 should correspond to the minimum one. So 20 will correspond to this, and 200 will correspond to 120, if you are getting what I'm saying. So it's nothing much. We'll just copy the volume percentage thing. np.interp 20 to 200. But now 20 should correspond to the bottom of the volume bar, and the bottom of the volume bar has a greater y value. So this will become 270. This thing will become 270, and the top is 120. So this thing will become 120. And this is not the volume percentage anymore. This is the volume bar. So let it be, my bad, volume bar. And now we have the volume bar, but we need to draw a rectangle inside this rectangle. So we'll copy the rectangle, and instead of 120, what we want is, we don't want to print as 120. We want a rectangle inside this rectangle, which will be filled, and this will be volume bar. So this will become volume bar, and we will do cv2.filled. Filled because we don't want it to be an empty one, and you'll see what I mean by that. Let my open up again camera. Okay, it closed because of some error. Yeah, because our volume bar is a float. So the error is that, see here, we converted the volume percentage into an integer, but when we put the volume bar here, it expects an integer again. So what we'll do is, we'll just convert it to an int. And now our volume control.py runs, and let's see, I have the volume bar. And as you can see, the volume bar moves along with my fingers on the left. It is much more convenient than the one below, because I can't open up the volume bar which is below every time. But every time I'm using this module, I can see the volume bar moving with me. Now, the last thing that we can do here is, the line also doesn't have any circles. So what I mean by that is, we can put in circles here. Let me show you. We can put in a circle at the tip of the index finger, at the tip of the thumb, and at the center of them, so that whenever we decrease the length of our decrease the length between these two fingers, we can actually see these circles coming closer, so that we can have a better visual representation of them. So inside the hand tracking module, where we had the find distance, we had a draw equals false, but we never used it. So if draw, we are only drawing a line inside this. But now let's put some circles. So we'll put a cv2.circle. Inside the image, we want to put one at x1 comma y1, which is the tip of the thumb, I think. Yeah, the tip of the thumb. We want to give in the radius. Let the radius of this circle be 15. And after the radius of the circle is given, we want to give the color. So let the color be purple itself, since the line is also purple. So we give BGR 255 plus 0 plus 255, that is blue plus red. And finally, we get CV2.filled. Now we'll copy this, we'll paste this 2 more times. Now this becomes X2, this becomes Y2, and this is purple only. So I guess this works. Now what is this third one for? We want the center of these 2 points also. So what is the center of these 2 points? CX comma CY center becomes equals to, if you guys know about floor division, how to find the center between 2 points in coordinate geometry, we do x1 plus x2 divide by 2, but this will give us a float, so we want floor division, which gives us an integer. And now y1 plus y2 floor division 2, so we get the center of these 2 points, and this will become cx and this will become cy. So now let's see what happens when we run the volume control again. So my camera opens up. As you can see, there are 3 circles now. One is on my the tip of the index finger. Second one is on the tip of my thumb, and the third one is in between them. So when I decrease the distance between them, you can see the circles coming closer, and it's a lot more visually appealing. And now our volume control part is complete. And if you see on the bottom right, I'll just open up my volume bar again. And if you see, my volume also changes with this. And one final thing we'll do here in this volume control thing, let's delete this one, it's a little messy. So what we want is, every time my hand opens up, even if I don't want to change the volume is being changed. So what I want is, when all of my fingers are up, only then I want the volume control to work. So what I can do here is, after I have the LM list, I can call the fingers equals detector dot fingers up, and what all are required in the fingers up. Let's see, we want the image and the LM list. So we have the image and the LM list, and is the draw equals to true? Okay, so we don't want to draw the count of the fingers as we drawed earlier, if you guys remember, like it was showing 1 if one finger was up, 2 if 2 fingers were up. So we will give in as false here. That is why we've given the draw variable false. Sorry, false. So now we have the fingers, and what we want is, if fingers equals 1 comma 1 comma 1 comma 1 comma 1, that means all the fingers are up, only then we want all of this to work. So we'll just put a tab and we'll put it inside this fingers thing. And what will happen now, that my volume control will only work when all of my fingers are up. You can map this to any other array you like. You can map it to, for example, you only want those 2 fingers to be up which you're using, but I've set it to all my fingers up so that it's a little convenient for me. So volume control dot pi, okay, I put an equals instead of an equals, my bad. Now my camera should open again, and I'll open up my volume bar. So yeah, 1 second. As you can see, all of my fingers are up, but it's not working. Let me just check 1 second what's wrong. Volume control dot pi. If fingers equals this, then we want to do this. I think it should work. Hmm. We have the, let's try this once more. Okay, so I have my fingers, but it's not detecting. Okay, why is that? Python volume control dot py. Yeah, volume control dot py is running. If I have my finger, okay, let's try printing the fingers to debug what's really going on here. Print fingers. Uh, First of all, if lmlist is there, then the fingers are getting detected. Then we have the fingers printing, and if fingers is equals to this 11111, then we have all of this going on. Okay, let's see. Okay, so I see. 1 second. I think what's happening. Yeah. My bad. So it was a very silly mistake. In the fingers of function, we're actually returning 2 things: the fingers and the image. But I only took it as fingers, so that's where the problem is arising. My bad. Sorry for that. Now, if I don't print the fingers, it's fine. Let's see Python volume control.py. And as you can see, only when all of my fingers are up, the volume control thing works. But when I put even one of my finger down, for example, if I put my middle finger down or my 2 fingers down, it doesn't work. If I put one of my fingers down, it doesn't work. But when I open it up again, it works. So that is how you can fix your volume. For example, I want to fix it to 50, then I'll just do this and I'll close some fingers. And for example, I want to put it to 50, I'll close this and my volume is set to 50. So you can map it to any other finger array you want. but this was just the demonstration of the volume control. So I hope that all of you got what all has been taught till now. And now we'll take the 1 hour break that is supposed to be in between our two sessions. So the first session is complete. Till now we have completely built our hand tracking module. We have done the scroll feature where you can scroll using your fists. We have done the volume control part where you can control the volume of your PC using your distance between two fingers. And that is quite a lot of the portion that we had to teach. So yeah, we'll be taking the break now, and thank you. We'll resume back in an hour. So, hey guys, welcome back to the third session of ACM Summer Bootcamp. And I hope that you guys are freshened up after the 1 hour break. You had your lunch and everything. And if you had any doubts of what we had seen till now, then you have clarified them by pausing the video, going back. So, let's see what all we have done till now. Let's start with the scroll feature. We'll first let's see the hand tracking module, what we have done in that till now. So we made a class called hand detector and we created a function called lmlist, which was giving us the landmarks for all the different 21 landmarks that MediaPipe provides us with. So this lmlist contains returns that. Then we saw the fingers up method where we are seeing which fingers are up and we are drawing the number if we want. How many fingers are up? This returns an array like 1 1 1 1 1 if all the fingers are up, and 0 0 0 0 0 if all of them are down. You get the idea. And finally, we saw the find distance method where we were finding the distance between 2 points P1 and P2, which we used in the volume control part because we were trying to control the volume of our system with the distance between our tip of the thumb and the tip of the index, this and this. So these are the three functions that we've seen till now in the hand tracking module. And let's see what all we have implemented till now. In the scroll feature, what we have done is we have taken the image from our video. We have got the lm list from the lm list function. Then we have checked if there is lm list. If not only our face is showing, but there is a hand indeed, then we're getting the fingers. And if our fingers shows that all of them are down, then we scroll down. And if all of them are up, then we scroll up. And let's quickly see the implementation of this, whether it was successful or not. Python scroll feature.py. So now my camera should open up. I'll go back to media pipe. I'll pin my camera just a second. Yeah. So now, as you can see, when I close my fist, it scrolls down. When I open my fist, it goes up. So as expected, the scroll feature works. And as you can see, it even tells me the count of my fingers. For example, one finger is up, so only one shows. Two fingers up, two shows. Three, 4, 5, so it's scrolling up. 0, so it's scrolling down. 1 stops scrolling. So the scroll feature was this. Now moving on, let's see what we did with the volume control. Uh, in the volume control, what we did was we learned about PyCore, which is a great volume control Python library given by Andrew Medas, and the GitHub link for that is in the chat already, YouTube chat, and I'm sure that you've seen it. So we took this piece of code from there, and we have already installed it from the requirements.txt. We got the minimum volume, the maximum volume, and we learned how the interp function works in NumPy. We saw that we're converting one range into another, and we calculated the volume based on the distance between our. Here we find the fingers, and if all the fingers are up, only then we are using the volume control feature. So if they are all the fingers up, then what we're doing is getting the length from the find distance method, and after we get the length, we're converting that length into volume using the interp function. We're also getting the volume percentage in a similar manner and the volume bar. So we are drawing rectangles. We are putting some text. The first text here is the percentage of volume that we are getting. The first rectangle is an empty rectangle and the second one is a filled rectangle. So let's see how our volume control one is working and then we'll move on. So let me bring this to the center. As you can see, as all of my fingers are up, it is into the volume control mode. So now if I increase the distance, the volume increases, and if I decrease the distance, the volume decreases. And if two of my fingers are closed, then it does not work. Yeah, it does not work. But when I open all of them, then it works again. So this works as intended. And this was the volume control feature. Let me just open up my volume bar if you want to see there. As you can see, my volume bar changes with the distance between my tip of index and tip of thumb. So moving on, let's close this up and I'll increase my volume to full. Now let's move on to the final part of our session where we'll be learning how to control the mouse pointer, which I'm currently controlling with the mouse, but we'll learn how to control this mouse pointer using your finger in front of your webcam, specifically the index finger. The index finger means landmark number 8, the tip of the index finger. Okay, so first what we'll do is we'll create a new file. Let's name this file mouse control. dot py. Okay, and what we'll do is, let's take the tester function and I'll explain what we have done there step by step again. So first we imported OpenCV, then we imported media pipe as MP, then from the hand tracking module. What is this hand tracking module? This is the script that we have written ourselves, the hand tracking module.py. So from the hand tracking module, we have imported the class hand detector. This is the hand detector class, and there are three methods inside it. So we have made an object of this class in detector. Then we have started the video capture of OpenCV using cv2.video capture. The webcam number varies for you, as I've already told at the beginning of the session. This is 0 for me, it may be 1 for you. And then we enter an infinite loop where we're getting the video capture, the frames. The success is the Boolean value whether we're getting a capture or not. Image is the numpy array, which is basically all images. lmlist is the detector.lmlist function is being called here, and we're passing in the image. As you can see, we have a detector.lmlist function here where we're just passing the image. I already told that self is self-explanatory, it doesn't need to be passed, and draw is default true, so we don't need to change it. So we have the lmlist now, and we don't want to print it. Okay. Now what we want to do is, like I said earlier, if lmlist, we want to check if there is an lmlist, because I don't want to move my mouse without any finger being there. First, we have to make sure that there is a hand in the frame. So if we have an LM list, what we want to do is, the main actor here is the tip of the index finger, which is the 8th landmark. So what we'll do is we'll get the coordinates of those in our LM list. So x1 comma y1 becomes LM list of 8 comma not comma, sorry, 1 colon. So as I told earlier, since LM list contains all the landmarks in a 3 tuple form, where the first is the ID and the second is the x coordinate and the third is the y coordinate. So 8 means we'll get the 8th tuple, which corresponds to this one, and the 1 index corresponds to the second element, which is the x coordinate, and the colon means that it'll go to the end, which is the second element, third element, the y coordinate. So if there is any doubt, I'll just come back here. The each landmark is like ID, comma, coordinate of x and coordinate of y. So we got this using LM list of 8, and the 1 corresponds to this and the 2 corresponds to this. We get the 2y colon. So yeah, we get the x and y coordinates of the index finger. Now what we need to do is we need to import PyAutoGUI. We have already used PyAutoGUI in our scroll feature. Let me just go back there. As you can see, we imported PyAutoGUI as py, and when we were detecting that the fist is closed, we were scrolling down -50 using the function py.scroll, and when it was completely open, we were scrolling up using py.scroll upwards 50, like plus 50. So what we'll do is similarly with PyAutoGUI as py, and now let's comment all of this, and I want to show you guys something. So you can check this for yourself, and I believe most of you will have the same value as me. But what you want to do, you want to check the size of your screen. Till now, we were dealing with the size of our image, 640 into 480. So we have our image. The X was 640 of our image, which is the image that comes on when my webcam turns on, and this is 480. So this was the size of the image. But now that we want to move the mouse in uh, time in our screen, we have to figure out what also, because we can't just within the image. So one in PyAutoGUI called py.size. So now let's run file mouse control. I'll see it's of 1920 and a height of 1080. So basically what this means is that my screen resolution, as gamers call it, or my screen resolution means my width pixel is my resolution. An image of 480 and this is 640. So we need to convert any motion of my finger here to the of the mouse pointer here. So sorry for the bad drawing. Now let's uncomment these things. So what is happening here? We saw that we had a very useful function in NumPy for converting ranges called interp. So what we'll do is we'll import NumPy as NP, and let me show you what interp was doing. As you can remember, interp was taking a value, for example, length between our two fingers in the volume control case, and it was converting it because the length we printed and we saw that it was between 20 to 200. So we were converting it from between this range to between the volume range, that we can get a volume proportional to our length. So similarly, what we'll do, there's a function in Py2 called move to, which actually means that whatever coordinates you pass inside this, it will make the mouse move to that. So I have these coordinates of my tip of the index finger, x1 and y1. But if I do this, then as I said, I will only get a value in this range, 640 to 480. But I want a value in this range. So what I have to do first, I have to get the new position of x. This pose of x will correspond to the x coordinate I want my mouse to move to, which is not x1. So what I will do is p dot interp. I'll write the code and then I'll explain what I'm done here. So first I pass x1, then what I pass is the range in which my x1 can be 0 to 640, which is the image coordinate. And from 0 to 6, from this into 0, 1920. So I guess your understanding is happening here. I get the x coordinate of my tip of the finger from here. Suppose this is x1, y1. I'm taking it from converting it into this range, so that whenever my finger get the coordinate intended in the screen. So this is my pose x. Now I'll just this and paste this, and I'll make this as pose y. y1 480 and 1920 will become 1080. The same thing we have done for this. You understood. Now py.move to will become pose of x, and this will. So this should work, but this is like very rough. Let me show you why it is very rough. Let's see if it works first of all. Let's do Python mouse control. Yeah. So I'll pin my, okay, my mouse has already started moving because of my finger. Just let me close this 1 second. I have to pin it separately, 1 second. Hmm. Okay, so as you guys can see, this is kind of rough because like even though it is moving with the help of my finger, it's shaking a lot. So let me just frame, let me just get this once. Yeah, 1 second, I'll close this again. As you can see, this violent shaking is not letting me actually use it to any beneficial purpose. It's very rough. So what is the reason for that? The reason for that, 1 second, why is it not switching? Okay, I think I pinned this. Yeah, it's my bad. Yeah. So what's happening basically is every time there's even a small movement which is unintentional here in my image, because the image is very small. So small movements are also being mapped to large movements in the actual 1920 into 1080 screen. That is the reason for this violent shaking. So what is happening is the small movements here, which is maybe unintentional, it is being translated to large movements here. So what we want to do is we want to smoothen it a bit. Okay, so how will we do the smoothing? So for the smoothing, we'll need some few new variables. The first one we'll call smoothing. Let our smoothing be equal to 7 or 5. I'll tell you what is the purpose for the smoothing. And there'll be 4 more variables, which is the current location of x, the current location of y, then the previous location of x, and the previous location of y. And I will initially assign all of them to 0. So what are we going to do with this? So basically, let me show you what I want to do. I want to do something like what is happening in our current scenario is that whenever our finger is moving, it gets the new coordinate instantaneously and it translates that. So it's moving very fast, like it's trying to move here to here very fast. But what we can do is we can slow down this movement to make it more smoother by dividing the actual distance it wants to move by smoothing factor, for example, 5. So for example, let's say this wants to move from here to here, and this also wants to move from here to here, and let's say the distance here is 500. So it will move at once to 500, and because of that, it's a lot violent and like a lot of shaking is happening. So what we want to do is we want to divide this movement by 5 or any other smoothing factor which we can change, and this will effectively move only 100. So it will be a lot more smoother, as you will see. So how can we do this is our current location of x will become the previous location of x plus our new pose of x minus our previous location of x. So what is happening here is our previous location of x is the location where we currently were, and our current location of x, our POS x, is the new one we want to go to. But we're finding the difference between these two. Like, we're finding how much do we want to move. This bracket thing is how much do we want to move, and then we divide it by the smoothing factor. So basically, if we want to move 500, it will only move by 100, and that will be the current location of x. So this will become current location of x, and this will become the current location of y. So let this become the current location of y. The PLOC becomes PLOC-y, the POS-x becomes POS-y, and the PLOC-x becomes PLOC-y. So pi dot move to pose-x and pose-y. Now let's see if it has gone any better. Acha, wait, I forgot to do one thing. Let me just, we also need to assign the uh, previous location of x is equals to current location of x, because then the previous location of x will not be changing how we want it to. So the previous location of y will become current location of y. So since this is an infinite loop, this should work perfectly. Now let's see. Okay, 1 second. Okay, there's still some shaking. Okay, so I think to resolve this issue, what we can do, we can make an if condition that only when our index finger is up, let's call our fingers function. I think that should resolve the issue. So fingers is equal to, oh, don't make the mistake again. So let's go back to the hand tracking module. In our hand tracking module, we can see that the fingers of function was taking the image and the LM list, and it was returning the fingers array and the image. And the draw was equals to true, so we'll make that false. So the fingers comma image becomes detector dot fingers up. It takes the image and the LM list, and will make the draw as false. Now we have the fingers array. So we want that our mouse pointer thing only works when our fingers of 1, which is the tip of the index finger, this becomes equals to 1. And okay, let's make it like wait, fingers equals 0 comma 1 comma 0 comma 0 comma 0. So what this means is only when our tip of index finger is up, only then this should work. I think that should resolve a lot of fake detections, which is currently the case with me now. I will move this, also take care of indentation. So we move all of this code that we had written earlier inside this if statement. Now let's see what's happening. Okay. So I don't think there's any detection. Okay, I need to remove this pin. Yeah. Now let's see. I have my this thing. Now when I put only my this finger up, you can see that the mouse pointer moves. For example, if I want to move to the right, it moves to the right, and when I want to move to the left, it moves to the left. Yeah, it's a lot more smoother too because of the smoothing factor. I can smoothen it further, and if you see that if I put two fingers up, then it does not work. It is now not working because we have put the condition that only when one of the fingers is up, it will work. So when I put one finger up, it works. And we can also make this a little visually enhancing by drawing a circle in the tip of the index finger. So what we can do is cv2 dot circle. Whenever there's only one finger up, which is the tip of the index finger, what we can do is cv2 dot circle. Inside the on the image, we will put a circle on the coordinates x1 comma y1. We'll put the radius as 15, and we'll make it a purple one. So like I said, BGR, and the blue plus red gives purple. So 255 comma 0 comma 255, and we'll make it as a filled circle, not an empty one. So cv2 dot filled. So this will draw a circle. Now, okay, the circle one should work. There's no problem in that. Let's test it once just for surety. So when I put my, okay, it's not drawing correctly. Yeah, it is. Now it's drawing correctly. When I put two fingers up, it doesn't draw, but when I put one finger up, you can see that it shows the purple circle. So that's okay. Also, one thing you will notice is, let me just put up my camera again really quick. Should not have closed it. It's actually inverted. So this is my right hand, and when I move to my right, when I'm moving to my right, the mouse pointer is actually moving to the left. So think of it like you're the user, and when you move to your right in front of your webcam, you also want to move your mouse pointer to your right. But in my case, when I'm moving to my right, the mouse pointer is moving to my left. So what I want to do is, I am currently moving directly to pose of X, and it did not smoothen because I did not put in CLOCY. So that was my fault. I should have put CLOCY. What was the purpose of calculating current location of X and current location of Y if we were using the POSX and POSY only? Now let's see what's happening. As you can see, now it moves smoother. The detection is a bit off for my tip of the index finger because of the background that I have right now, which is also kind of skin color. But if I move it a little up, you can see that, yeah, now it's a lot smoother because I had originally not put in the smoothing factor. So now it's a lot smoother. And if I put two fingers up, then you can see it does not work. But when I again put up one finger, then as you can see, it works. Yeah. So let's close this up. And the inverted thing that I was talking about, I am actually using my right hand. And when I move the right hand to the right, it's actually moving to the left because the image in OpenCV is actually inverted. So what I can do here is I can do 1920 minus CLOCX. So what is happening here is basically, let me clear this up again. If this is my screen and my CLOCX is telling me to go here, I will actually go here, which is if this is X, then this becomes 1920 minus X. So that is how we'll fix this issue because the screen is 1920 in width. Yeah. So I guess it should work. Now the thing will seem inverted to you, but as a user, it will seem okay to me because now when I move to my right, it is moving to the right. Yeah, now it moves to my right when I'm moving the hand to the right. But for you, it may seem due to the image that it's inverted. So if you're following along, then I hope that you also got this correctly. And now we can even increase the smoothing factor a bit to account for um, more smoothness. So let's make the smoothing factor, for example, let's say 10. And if you feel that the smoothing is making it a very slow, then you can decrease it a little. But I find that smoothing mouse control is a lot better. So now when my finger is being detected, yeah, the landmarks are a bit off. Now it's correct. Okay. So when I'm moving, you can see that it moves very little. It's actually a bit slow. So, but it still moves. So let's change this to maybe 7. 7 is an ideal value, I think. Yeah, let's get it up running again. And as you can see, now it seems perfect. Let's scroll to the volume control.py. Yeah, I got to the volume control.py. Now let's scroll down. And one more thing that you can observe here is now when I want to go down, right now I'm in the middle of my screen, but let's say now I want to move down and I go down and my hand detection stops because as you can see, let me go back to the MediaPy page. Let's escape this. So what's happening is there was a palm detection model which I spoke about earlier in this session. So there was a palm detection model, and you can give this a read. Basically, what's happening is that first the model detects the palm, and after that it gives the landmarks. So when I am opening my camera, let's do it once more, and I'm moving down, and my palm goes out of frame. For example, here the palm is in frame, but when my palm is going out of frame, as you can see, I'm in the middle of my screen only, but still the palm went out of frame. So the hand detection stops. And this is a problem because you can go up as much as you like, but you can't go down. So to solve this, what we can do is, let me show it in the whiteboard. Let's clear this up. So for example, you have your image and you can draw a square box here. And what will happen is whenever your palm is inside this region only then the detection will work. You will cut off this extra space so that you can make sure that your tracking works perfectly. Because when we're going out of frame here, this is not working. But even if we reach the bottom here, this is our palm and these are the fingers, it will work because the detection is still happening. So what we want to do is we want to reduce the region of detection even further inside our image. So how will we do that? We'll declare a new variable called frame R. Frame R will be frame reduction and let this be 100. So what is this frame R? This frame R is the frame reduction which we are doing on all the sides. For example, this distance, this distance, this distance, and this distance. Sorry for my extremely bad drawing. Um, this is frame R. This should be 100 pixels. So what will happen is basically this was 0, 0. So this point will become 100, 100 if our frame R is 100 because of the 100 distance. And what will happen here is this point was 640, 480, but this point will now become 540, comma 480 minus 100 is 380. So yeah, that is the frame reduction. Let's clear this out. So now what we want to do is first let's draw a rectangle. Okay, we want to draw the rectangle. So CV2 dot rectangle, and let's see, we might have used the rectangle somewhere. I think we use the rectangle in the volume control. So let's copy from there. Let's take this and copy paste it here. So we are putting in a rectangle on the image. That's correct. Now this is the coordinates. So the rectangle coordinates will be the top left coordinates, as we have seen, will be the frame R, comma frame R. The rectangle top left means this one will be frame R, comma frame R. So let's convert this to frame R. Yeah, the top left coordinates become frame R, comma frame R. The bottom right one becomes this coordinate was 640 into 480, so this one will become 540 into 380. So let's see if that works. So this will become 540 and this will become 380. The color, let's make it purple, 255, and CV2 dot not filled. We want it to be an empty one. Let's decide the thickness to be 3 pixels. Let's see if we get the rectangle. Python mouse control. So now when I put my, since the rectangle thing was inside the if statement, you can see that when I put all of my fingers or 2, 3, 4 or 0 fingers up, it does not work. But as intended, when I put one finger up, you can see that the rectangle has been drawn. So the rectangle is drawn, but still the detection does not work when I go down because we have not mapped it correctly. When I go down, the detection stops midway because my palm detection model says that there is no fist in the, there is no hand in the frame. So let's change that. Pressing escape, we escape. And if you were wondering, the escape which I told earlier was due to this wait key thing. Coming back to the rectangle. So basically now what will happen is our pose of X and our pose of Y were mapping 0 to 640. So what I'm trying to say here is, let's clear this out again. I'm only drawing rectangles today. So this is the camera image and this is the frame reduction. So what is happening right now is it is taking the X coordinates from 0 to 640 and 0 to 480. Like it is taking the whole thing. But now since we've drawn the rectangle, we want it to take this region only. And it was here taking 0 to 480. If we move back, this is 0 to 480. But now we want it to take this region only. So what will happen is, it's very easy. The 0 will become frame R. And the 640 will become 640 minus frame R. And the 0 will also become frame R. Because like try to understand, like it was 0, 0 means this, and sorry, 0 means this, and 640 was this. But now frame R becomes this, and 640 minus frame R becomes this, the two limits of the X coordinate. So this becomes 640 minus frame R. And now initially for the Y thing, it was 0, 480. So 0 being this and 480 being this, but now we want this, which is frame R, and this becomes 480 minus frame R. Yeah. So do we have to change anything else? I don't think so. We are only detecting now within the inner square slash rectangle. It's a rectangle, yeah. And it will translate that movement into this on the screen movement. And the smoothing is 7. So I think it should work right now. The fingers being 0, 1, 0, 0, 0. Let's see. Let me run my code again. So let me pin this to the screen so that you guys can see. I'll pin it now. Okay, the detection is working. Now, as you can see, even though I'm at the middle, it's going to the top. Like even if I go to the like top of the rectangle here, it's going quite up, whereas it was going to the exact translation earlier. So Now, as you can see, my detection is only working inside this rectangle. As I move to the extreme right, this moves to the extreme right. As I move to the extreme left, this moves to the extreme left. So yeah, and since there is a smoothing, there is a bit of a delay, which is actually pretty useful. So I hope that you guys have understood till now. And let's go ahead with the final implementation, which is the clicking part. So I'll give you guys a minute to take a breather, and if you want to see the code, here it is, and make sure that you catch up. So take a minute. Okay, guys, so we're back, and I hope you're up to date with what's happening. And there will be a certificate form coming up on the YouTube live stream, which is essential to be filled if you're watching the stream and you want to get the certificate for the session. So please make sure that you fill that form. It will be on the YouTube live chat shortly. And let's move on with the final portion of our workshop, which is the clicking part. So what do we want to do? Let's see. Let me clear this out again. So we have our two fingers here, the tip of the index finger and the tip of the middle finger, which is 8 and 12. What we want to do is we want to click whenever these two touch together. Like whenever we put the middle finger up and we tap them, we tap the tip of both of them. We want that clicking action to be performed. Now you know this is very easy since we only need the distance for this, the distance between the two. And we have already made a distance function, which is the find distance. So what we can do here is, and now we also need to change this. So what we'll do here is, if fingers of 1, which is the index finger, if the index finger is up and fingers of 2, which is the, oh sorry, not excuse me, this will be and. Yeah, I'm a bit of a Java fellow, so the and came from there. If fingers of 1 equals 1 and fingers of 2 equals 0, which means that the index finger is up but the middle finger is down, then our normal mouse movement with our finger will work. But if our fingers of 1 equals 1 and our fingers of 2 also equals 1, what we'll do now, we will call the detector dot our what was the function name again? It was find distance. Yeah, dot find distance. So this will be our distance, and what are the parameters that we need to pass? Let's see. We need to pass 4 parameters: p1, p2, image, and the lm list. So p1 is the first point. So let's see what is the first point. 8. So first we pass on 8. Then let's see the second point. It's 12. So let's pass in 12. Then we need to pass in the image, and then we need to pass in the lm list. And now make this error that I made earlier with the volume control also, by not realizing that actually we're returning length comma image, but I'm only giving distance. So let's take distance comma image, and let's go back and check if a draw is equals false. So draw is equals to false, and we don't need to worry about that. What the draw was doing, if you remember in the volume control case where we had made it true, was that it was drawing a line between the 2 points we're finding the distance of. So basically what would have happened here was there would be a line between these two, but we don't need that. So yeah, we have the distance comma image. That is what we're returning, I think. Yeah, the distance comma image. Now let's see what the distance range is so that we can map it to the clicking function. Let's see, distance, go print. Okay, so now the distance thing will only get printed when I put both of my fingers up, and let's put it up. So as you can see, when I put both of them up, because it is in the elif condition, we get a distance. Now let's try to decrease the distance and see what is the lowest it goes. The lowest the distance goes is around 20s to 30s, I think. I think 30 is a good value, yeah. And when I start to increase the distance again, it goes up to like 70s and 100s. So what we can do is we can implement the clicking action by saying that, hey, whenever the distance between my two fingers goes to less than 30, that time you click. So let's remove this. And what we can do is we can put an if distance is less than 30, then what we can do is we can do, as you know, we have already imported PyAutoGUI. So let's check what is the function of PyAutoGUI that will allow us to click. Clicking action, mouse control functions. So let's see. The size gives us the resolution of the screen, which we have already seen. The position gives us the current position of the mouse. Let's control F and see how to click. Py_click. It's a simple and sweet function. Py_click. But since we've imported py as py, what we can do is py.click. And I think that is it. So let's test this out. Let me do Python mouse control.py. Okay. So yeah, let me just get this up once more and I'll pin it. Okay, this is clicking very violently and I need to figure out why that is happening. Just a second. Yep. Let's see what's happening. Why is it clicking so violently? So what is basically happening here is if LM list, then we are getting the fingers, and if fingers of 1 equals 1 and 2 equals 0, we are doing the thing. But why is it clicking so violently? Acha. So we're clicking like this because what is happening is actually at my back, the background is making like some other hand detection happen where also those two fingers are up, which is kind of spooky because I'm alone on this floor and I don't know why it is detecting like that. But yeah, so I think what should fix this is fingers equals 0, 1, 1, 0, 0. So this will make sure that not only are these two fingers up, but the other three fingers are down. Only then it will click. So I think this should be pretty good for what we're trying to achieve here. We find the distance, and if the distance is less than 30, then we click. So let's see if this works. My bad. Equals. Okay, now the violent clicking has stopped, but fingers is not defined because I have put fingers somewhere, and which is here. Again, my bad. So now, as you can see, when only one finger is up, the rectangle gets drawn again and we can move the mouse around as we want. But when the two fingers are up, the rectangle goes away and we can implement the clicking. So let's try to minimize this video feed that I'm getting from OpenCV. I'll move up and as you can see, when I click my two fingers, it closed. So let's try to change the tab to volume control using my finger. So I changed it using my fingers. And this is pretty smooth because we have applied the smoothing also. And as you can see, all of this I'm controlling with my fingers. So if you want to see me doing it live, what I'll do is I'll pin this and just a second. Yeah, I will pin this one second. It's still detecting a hand behind me. I'll just move here. Yeah. Yeah, I pinned this. So now what we can do is, let's see, I have this finger up. And as I move, let's turn to VS Code only. Yeah. So when I move here, let's say, for example, I want to minimize this only. Then I move up and here, and I minimize it using my fingers. And this also I'm moving using my fingers. So you can further smoothen this by adding one or more smoothing functions, but I don't think it's required as of this session. And that was pretty much it for this. One more thing that we can try is we can try equating this fingers array equal to the 0, 1, 0, 0, 0. I think it should make a difference. Let's try that out. So yeah, now let's try changing the tab with my finger. Let's try changing it to volume control.py, and we were successful. Okay, let's switch back to mouse control.py. Successful. Let's try to pin it so that you guys can also see. Yep. So even though the hand is getting directed behind me and some hands are there, it does not affect that much because now we're checking for all 5 fingers because we know what we want, and the hand behind me, which is the ghost hand, does not know. So I can move around the edges here. Let's try to change the tab using my clicking action. Volume control changed. The scroll feature changed. Volume control again. And yeah, it works perfectly. So let's see what else. I think that is it. So to summarize what we've done in the total session till now, we have used the tester.py, and initially we tested on the initial static image hands.jpg. Then we moved on to the video frame capturing, and then then we started with the hand tracking module. This is the most important thing. So what I want you guys to know is that this hand tracking module can be used by you in different scenarios. Like, you have so many good functions here. You have the lm list function here, you have the fingers up function here, you have the find distance function. What else do you need in hand tracking? You can map anything to anything. You want to do any other task with hand tracking, you can use pretty much these functions and make little alterations to your liking. So don't worry, all of this code will be going to GitHub, and we'll also be posting the GitHub, our Discord, after this session. So you can find all of this code even if you missed out something. So you will find all of that on GitHub, all of this code. So as we were summarizing, this hand tracking module can be very useful to you. With the help of this hand tracking module, you can in our scroll feature, we have directly made an object of the in it, and then we simply called the lm list and we have checked the scroll feature. Then in the volume control also, we use PyCo for the volume control part. Thanks to Andrew Midas for that. And we have used functions such as fingers up, find distance, and we have used numpy.interp. Pretty simple stuff. So, and finally coming to the mouse control, we have seen that we applied a couple of things. So to summarize the mouse control part, first of all, it was very rough because we were directly translating our movement from, let's see, we were directly translating it from 0 to 640 to 0 to 1920. Then what we did was frames. We removed 100 frames here. So it started from 100 and it ended at 540 so that our palm detection model did not get confused. Where is the palm? Now this get maps to 0 to 1920. Then we further applied a smoothing factor so that the movement does not take place at once. For example, if it wants to go from point A to point B in suppose very fast, for example, the distance is 500, so it will go to 500 at once, which is why the shaking was so terrible. By let's say 7, and we got a less value. So yeah, that was the smoothing part. And I think one more thing we did, yeah, we put the rectangle. So we got this part, the frame reduction part. And after we were done with the mouse moving thing with our finger, the tip of the index finger, what we did was we took the 2 fingers, which are these 2 fingers, and we made the clicks. It's always better to take the fingers array and put it like this, because then you're also accounting for the other fingers, that the other fingers do not cause some trouble. So this is the exact configuration that I want when I want my fingers to be, controls. And this is the exact configuration I want when I want to click. So that's why in the end you could see moving so smoothly. That was it for the session. I hope you guys enjoyed it. So now we have some tasks for you guys. Coming to the tasks, what are these tasks? There are 2 tasks basically. The first task being that implement a drag and drop functionality using your tip of the index finger and the tip of thumb. So what I want you to do is, example, let me just turn on my camera and show you what I'm doing here. So what I want to do is, for example, this is your hand, volume control. Implement a drag and drop functionality. You want to pick up an icon. So you use it here, it picks up the icon, and you drag it and you drop it here. You can do that with the functions that we've given in the hand tracking module itself. That is the first task. So you take something, you drag it, and you drop it. So that is the first task. And the second task is very simple. Like the volume control, we could change the volume with the help of these two fingers. You can do a brightness change. You need to figure out how to change the brightness of your system with Python. But yeah, that is the second task. So how are we planning on taking this submissions? What you can do is we want you to record yourself after you have made this task. Even one task will work, but we encourage you to go for both of them. So what you do is make a YouTube video recording yourself with what you have implemented, and you in the description of the YouTube video put your GitHub repository link of the code that you've written, and the YouTube video, what you can do is the link of that video you can put in our ACM Summer Bootcamp server in the task submissions channel in the ML workshop part. So when you go to the Discord server, you can see there's an ML workshop channel, ML workshop subsection, and there's a task submissions. Here you can put the link of your YouTube video. We'll put the instructions here also, don't worry, but yeah, that was for the tasks. So the two tasks are drag and drop functionality using your tip of index and tip of thumb, and the brightness control using your these two fingers only. Those were the two tasks. And one more thing, now in the chat there will be a repository going which is of ACM VIT. So let me just show you real quick. So basically what I'm trying to say here is that we have at ACM VIT an open source initiative where we encourage like all the people in the college, everyone who is into open source, to actually try and contribute to our repositories, and we try and contribute to other repositories. We have very talented people in ACM, and we love what they're doing with open source. So there is this repository that we have created. There were also repositories for the web and the app workshop, and you may have found them also. You can find them here also. But for these for the research this workshop, you can find an open source repository here, the ACM VIT virtual trainer. So this link will be in the live chat shortly. And what you can do is, we have a couple of issues here. For example, a push-up counter, a stop and play for media player, a stop and start, a timer countdown. And some issues are here, how correct a yoga push is. So what you can do is, if you want to contribute to this repository, you can solve these issues with your Python code or whatever, however you want. You can take whatever we have learned in this session and do it. And when we go to the media pipe, let's see, what do we have here? We have for the push-up counter, maybe you can use some pose detection, some holistic. It's for you to figure out, and you can contribute to our open source initiative. So the link will be in the live chat shortly. And finally, we have at the end of our session, what we had planned is that some members from our research core will come, like they had in the app workshop, and they will talk about their experience in ACM and how is college and what they're doing right now. So let's end this session with them being live and them talking about themselves. And yeah, let's go.
Hi guys, I'm Aryaman, a fresher from ACM's research domain, and my journey at ACM has basically been an exciting adventure. So to put things to perspective, if you followed along today's boot camp and successfully executed the gesture control, then you would have got this rush of excitement of actually coding something really cool. And that's exactly how I felt when I joined ACM. And when I saw everyone working on these cool projects in web, app, and machine learning, so I saw people from the research domain doing competitive coding and learning web development, and I saw people from the web domain applying their deep learning models in their websites. So it didn't matter which domain you were in. What mattered was actually your idea and how willing you are to execute it. And I think that's the most important lesson I've learned from everyone here. So yeah, that's pretty much it from my side. Stay tuned for more, and I'll catch you all next time. Bye.
Hi guys, Manim here, and I'm a part of ACM's research domain. So I got into ACM in May, and ever since then, I've had one of the most fun and educative experiences here with absolutely brilliant seniors and supportive batchmates. So for me, ML has always been a subject of interest because machines being able to learn automatically by experience is something very similar to human behavior, and it makes it a worthwhile real world application of computer science. I also want to thank my seniors today for hosting such a fun and informative workshop because I enjoy working on ML based technologies a lot. And to all the attendees, I hope that today's workshop helped in inculcating an interest in computer vision for all of you. And you guys can build on top of what you learned today in the future. So until next time, bye bye and take care.
Hello everyone. Hello everyone. This is Tilek Chidambaram from the research team ACM. Being a part of ACM has enabled me to explore myself and the interest within myself. As a fresher, I need a good mentor and a senior who guides me throughout my learning process. ACM provided me with a good seniors who gave a good outlay of all the domains I'm working on currently. Is, as you know, it's one of the most fascinating and interesting domain which is applied in every field. So just like adding salt to the food, we are applying in every other projects we do just to enhance the efficiency and the workflow of a project. You know, as I said, ML, there are a lot of steps you can learn as we did today. There are a lot of cool stuff we can do with OpenCV and all other libraries in Python. Hope you guys explore more about this field and enrich your knowledge, ACM. We feel free.
All right, so guys, I was the speaker for today's session, and let's conclude the session. I hope you guys enjoyed it. You can always reach me for doubts in the Discord server, and you can always contact me. I hope that I was not going a little fast and you guys caught everything. And don't worry, even if you have doubts, then all the code will be there on GitHub, and you can always contact me for anything that you require, any doubts that you have, or if you have any interest in this field. So signing off, Vinamra, the research lead of ACM, and thank you for attending.